Hi guys, welcome back. We are going to be working with section 2.7, linear inequalities. And so we're going to be discussing what a linear equality actually is. So it is a two-variable inequality whose solution is a shaded region on the graph.
Could I please have a custodian call 802? Could I have a custodian call 802?
And we love announcements in the middle of our videos. So moving on. With a linear inequality, linear usually referring to a line. Inequality, we've talked about less than or equal to, greater than or equal to, so we're going to be working with that as well. It is a two-variable, meaning that you're probably going to have x and y. So that typically means that you might have an equation of a line, so y equals mx plus b. And the solution is a shaded region on a graph. So it's more than just one answer. It's more than just a number line. You actually have to use an entire coordinate plane in order to figure out multiple solutions that are going to work for this inequality. Friday afternoon, we'll get there. So for very important concepts, we have our greater than sign and our less than sign. Both use dotted lines. So when you graph these, you're going to be using a dashed line. If it is greater than, it means that you want your solution to be greater than those values, so you're going to shade above. If it's less than, you're going to shade below because it's going to be less than your line. If you have a greater than or equal to or a less than or equal to, you are going to use a solid line. Sometimes they think about it for the fact that you have this extra mark here, so we want to make sure that it's nice and filled in and it's solid. So they're both solid lines if they have the equal to part. And again, if it's greater than, you want to shade above, and if it's less than, you want to shade below. More importantly, you're always going to test the point 0, 0. It's the easiest point to test to determine which part do you actually shade, and you'll see what we mean in a minute. So if it works, you want to shade that part. That is part of your solution. 0, 0 is part of your solution. If it's not, shade the other part instead of. So our first example is y is greater than or equal to negative 1/4 x plus 2. With that being said, you want to acknowledge the fact that it's almost like a line in slope-intercept form. You have y equals mx plus b, except now we have an inequality. So this is where we incorporate that shading aspect. So the greater than or equal to means that you're going to have a solid line. So you graph this just like you would at any other point. You start at your y-intercept at 2. You use your slope of negative 1/4, so you're going to go down 1 over 4, and you can also reverse it. And again, that is going to be a solid line. If this wasn't here, you would have dashes in this line. But now it's the point where we're not so sure of what to do next, so we test the point 0, 0. So for 0, 0, that's an x value and a y value, just like any coordinate point. And we have 0 for our y is greater than or equal to negative 1/4, again 0 for our x, plus 2. When you simplify that, this turns into 0, and you're left with 0 is greater than or equal to 2. That's not true. So do not shade 0, 0. If 0, 0 worked, then we would shade there. But since that is not a true statement, you want to shade everything on the other side. So this is not part of your solution, but all of these, hence why it's shaded in purple, is part of your solution. Goodness. Here's our second and last, thankfully, example. That y is less than negative 3x plus 5. So in this case, you want to be aware that we don't have the equal to part, in which case it's a dashed line. So here we start at 5, we go down 3 over 1, down 3 over 1, down 3 over 1 to plot our points to make this line. But because I don't have the equal to, that's what makes it dashed, meaning that you can't use the values that are on this line. And again, well, what part do I shade? What's my answer? So you want to test 0, 0. So you substitute in 0, 0 into your equation. So 0 is less than negative 3 times 0 plus 5, which is what's represented here. And 0 is less than 5. That's true. So that means that 0, 0 is part of my solution. I want that to be the shaded part of my solution. So we're going to shade in that direction.